Good morning, Year 10. It's Mr. Sutton here. Today we're kind of sort of mopping up a few bits and pieces and trying to finish off some of the theory that we need to go through. What I do have is, first of all, our tools bits and pieces. If you remember in the last video I mentioned about not having completely finished with two sets of tools. Now those were the one I have here, which is a metric vernier caliper. Well, I don't have it here, I have a video of, and also a micrometer, or some people will call it a micrometer, but it is a micrometer, and this one is metric. Now I've got two general videos about these bits and pieces. They are quite straightforward and simple. I'll link to these ones, and they're also in the playlist as well. It basically talks about how you can actually use first the vernier gauge to measure things. And what is quite nice is it's nicely sort of animated here with this Mr. Bob Welds, and it talks about how to read a vernier gauge. Now a vernier gauge, if we go back to the beginning part, you'll see that what it has is it has two kind of jaws. Normally these are slightly different shaped. What it can do is it can do an internal measurement and it can do an external measurement. An external measurement is where you move this bit along this lower jaw part and place an object in between it, tighten it up again, and the scale that's read here in millimeters will give you the diameter or width or whatever size that particular object is. The great thing about these at the top though, normally with a sort of vernier gauge, they're a little bit smaller, and what they allow you to do is they allow you to actually read the internal measurements. And we'll just see if we can, because he comes along these ones, you can see just here. So this can be used, and they cross over so that it could do an internal measurement. So both of these sides move outwards, and obviously can go into, say, a hole that you've drilled or something like that to get an exact measurement for the internal diameter of something. So they are especially useful for these two key parts. I'd like you to just tack these onto the end as an additional one. So one for the vernier gauge, an image. It's a good idea if you have something like this so it's open as well, an image that shows it open so that you can figure that one out. A micrometer is another means of doing a similar kind of task. Hold on, let me just mute him, Mr. Welds. You will see with this one, you have this bit just here. This bit moves in and out. They're very, very accurate. You can see here that it's got 0 to 25 millimeters is its range, which is not much, 2.5 centimeters. It's not a great distance, but that's kind of the distance between this section just here in the jaws, and it's actually got an accuracy down to 0.01 millimeters. So it's a very, very fine checking and measuring item, and you can see just on here the sort of fineness you can get on these, and that's a real life one, and by all means have a look at some of the videos of real life ones. The good thing about this is it does actually show the sort of reading of it, because you can see that how it is read is this bit just here. So you can see this is 0, 5 and 10, so you've got 10 just there, and each one of these is a millimeter. So with this it would be 11, 12, 13, 14 millimeters would be what that is. Well, actually just very slightly over 14, 14.1 might be something that you were doing with that one. And so that it allows you to very carefully measure. You can see here it also talks about this being 0.01, where you've got even a finer gradation, where they'll even have even smaller little lines on these that can help you to do even more precise measurements. Now these are very, very accurate, and they need to be kept very, very carefully and used. They have polished surfaces on the end, and they're very, very useful for using with a lathe to make sure that you're cutting something down to an exact measurement. So I'd like you to add in something about the micrometer and also something about the vernier calipers as well, just so that you understand what they are and how they're used. Use these videos to help you out. By all means, use a screen capture from them if you wish. Now, the other thing that we need to talk about and to do is something we call risk assessment. And I'm using technologystudent.com as per usual. Good old Mr. Melanie, they want to put it on here. If you would like to just put in risk or risk assessment on there, it'll bring up the health and safety and risk assessments. Now, a risk assessment is something that you have to understand, and it's something that we do within school all the time, and we do it for both hand tools, chemicals, and also machines to try to decide on what the potential risks are and try to reduce them. So a risk assessment is where you will look at something, an activity or a tool or a machine, and decide on what the risks are to the user and the people around. So you can see just here, we've got a nice little animation of this guy, Mr. Ryan maybe, and he's actually drilling something using a pillar drill. This should be quite, useful for you. You've all used pillar drills before. You can also see that it's got a close-up of the start button. It seems to be implying it's on the top there or just on that side. And it talks about the hazard, the level of risk, and the control measures. And they are usually split up into these 3 individual sections. Hazard, for example. There's a possibility of sharp, extremely hot metal swarf, that's the little bits that come off, flying off at high speed in the direction of the operator. So we've got, with the animation just above, you've got the pillar drill drilling a piece of metal. We know that drilling a piece of metal, it does actually produce those shavings which can be quite hot because they've been heated up by friction. It's got a close-up here, and we're then talking about the level of risk, and we're saying it's a medium level possibility due to the physical properties of sheet steel. So you have to make a judgment, and this can be quite tricky because obviously this is usually based on your own personal experience, and sometimes you may not have had as much experience of it. So you've got the hazard, and there can be multiple hazards. What the level of risk is, medium, high, low. And then finally we have probably the most important measure on this one, and that's the control measure, something that reduces the risk to the person or the people around. So fit the guard, making sure that the guard is down. Ensure guard is in position. Wear goggles supplied. Foot stop for any emergency. Staff training so people understand how to use the machine, so the drilling is controlled correctly by the operator and the risks are understood. Appropriate protective clothing is also prepared, so you're not doing it there in a t-shirt and all that type of thing with short sleeves that might hurt you. And also you could also talk about having the work clamped down to the base to make sure that it's supported, that it can't spin. There's many different things that you can do as your control measure. So that would come into the level of risk or even into the hazard. So you could put in here, there is a hazard of the work being caught by the drill bit and spinning round. Level of risk could be medium again due to the type of plastic. Say if you were doing plastic, for example, that would even be maybe even a high risk. If you're drilling a smallish hole or a large hole, would make it even more dangerous. And then control measure with that one would be that you would bolt it down or clamp it down to the surface, so therefore eliminating most of the risk. So you can see in this table that we've got below, hazard is a possibility of sharp, extremely hot metal swarf flying at high speed in the direction of the operator. The risk level is medium due to the physical properties of sheet steel. And then you have the control measures, what you can do in order to try to mitigate, to reduce, maybe not completely get rid of, but certainly reduce the dangers to the operator. So fit a guard, we can see there the plastic guard. Ensure guard is in position so it's not just left out. Goggles must be worn, are supplied. Foot stop for emergency, so you are holding it so it can't spin round, so you have got something which you can use to stop the drill using your feet. Staff training, student training, so people know what to do. And also that the risks are understood so that they understand this one, so they know that there is a possibility. If you remember when I was talking about when we were drilling plastic, I said to you there is the possibility of this spinning around, even to the point of making it do it deliberately, or to shatter or to fly bits around, so that you understand what can happen and therefore you don't do it. When drilling thin materials such as sheet metal and perspex, it is necessary to secure the work in a vise or clamp it down. Complete the table below by identifying the risk level and any necessary measures. So we've got a similar type of thing here, and it's got a variety of different kinds of machines. Now you've got the buffing machine. Study the buffing machine, polishing machine seen opposite. Identify 2 hazards. In your opinion, what is the level of risk for each hazard? What could be the control measures for each hazard? And then to complete this table. Now what I'm going to ask you to do is I'm going to ask you to do it for the buffing machine. I'd like you to put in the one for the pillar drill so that you understand it, maybe add to it in the same one. And then I'd like you to choose a tool or machine of your choice. And if you really can't remember anything from the workshop, you could even do it with stuff that you've got around at home. So a electric drill, for example, the battery operated drill. There's something that you probably have got at home and you can actually have a go with. Even a handsaw. What are the potential hazards? What is the risk level of that happening? And what control measures can you put in place in order to sort that one out? Now, the Word document I have created, I'll just do a very, very basic one for you and put it in the table so that you can just fill those ones out. You can fill out the example one for the pillar drill. You can do the one for the polishing machine or buffing machine, which you've used. And things like, for example, it'll throw it out at you and it can get very, very hot. Those are two hazards that I would think about. And then I'd like you to choose one other. An electric drill or a handheld drill, be it battery or cable operated. But it could be something like a lawnmower. It could be any of those kinds of machines that you might have around the home. So what are the hazards? What is the risk level? What control measures? Even a kettle boiling water has risk level to it. Deep fat fryer, think about those. So I know that at the moment we don't have the workshop. It's really the exercise of working these ones out. What I'll do is I'll create that one. I'm expecting at least 2, I would say. I'm going to say 2, so we've got 4 in total of those risks and risk level and control measures placed in. Nice and straightforward. So just to recap, watch that, do a little sheet for it, watch that, add that to your show sheet, make sure they're printed out. Think about checking out these ones for risk assessment and technologystudent.com and complete the attached Word document with those extra 4. I'll have a look through all of those bits and pieces for you. We will be having our Monday's lesson. We'll be looking at, in particular, Gantt charts tomorrow, Monday. No, sorry, we're going to do maths. What am I saying? That's the week after. We're going to be having a look at the mathematics area, which I'm sure you'll absolutely adore. And I'm going to be doing some lessons on Friday to try and help support you with that for Monday morning. Okay, in Year 10, have a good one, and I will speak to you soon. Take care.